guys, so today we're going to be talking about BMW's N55 engine. It is an inline-six engine that is also turbocharged, producing roughly 365 horsepower at 6,500 RPM. It is seen on varying platforms from BMW ranging from their 2 Series, 3 Series, 4 Series, and even 5 Series, which is pretty cool. It has a ton of aftermarket support and a ton of tunability, which allows you to range the horsepower from the vehicle with just a simple tune and catless downpipe. And it's something I personally have done in my F87 M2. It's a ton of fun and with a manual transmission, and I can't say I've had this much fun in any other vehicle that I've owned, even with the small sample size. So yeah, now let's go into the engineering behind it. Alright, let's talk about the combustion chamber design. The N55 contains a pen-roof combustion chamber design featuring two 35mm intake and two 28mm exhaust valves per cylinder. The larger diameter in the intake valves allow for more cold air to enter the combustion chamber in respect of time that the valve is open compared to the exhaust valves, which push hot exhaust fumes to the exhaust manifold. This design choice also limits the risk for flow restriction within the intake manifold. Let's look at the fuel delivery system for the N55. The N55 uses many sensors to calculate the necessary amount of fuel needed during the combustion cycle. At varying RPMs, there are set values for the air-to-fuel ratio that the engine targets. The electronic control unit, otherwise known as the ECU, will measure the mass of the air entering the intake manifold by using varying sensors. The mass of the air is calculated using the measured pressure value from the MAP sensor times the vehicle's displacement, all divided by the product of R specific and the temperature of the air entering the engine using the intake air temperature sensor, otherwise known as the IAT sensor, times the volumetric efficiency and RPM over 120. Volumetric efficiency is an important component to tuning the engine. The ECU is programmed to input a certain amount of fuel into the combustion chamber based on the engine's RPM and the mass of the air entering the combustion chamber. The volumetric efficiency is a measurement of how much air can fill up the volume of the combustion chamber from top dead center to bottom dead center. The more air, the more fuel can be added to create power. However, there is a caveat, being that volumetric efficiency is not linear. To put it in perspective, it becomes very difficult to get enough air into the combustion chamber when at high RPMs, as the time at which the intake valve is open to distribute the air to fuel ratio is very quick compared to other loads. The N55 uses what is known as direct fuel injection. From the 52-liter gas tank, fuel is sent from the low-pressure fuel pump at roughly 30 psi to the high-pressure fuel pump at the engine. The high-pressure fuel pump then compresses the fuel up to 3,000 psi by pushing the pump's piston up and down from the lobes of the camshaft rotating. The pressurized fuel is then sent into the fuel rail and injected directly into the engine's combustion chamber. The N55 contains 6 spark plugs and ignition coils to produce spark within each combustion chamber. The spark plugs can be gapped anywhere from 20/100 of an inch to 30/100 of an inch, depending on the fuel that is used and whether or not you are forcing more boost into the engine. Having a smaller gap can also reduce the risk of blowout. The N55 uses BMW's well-known Valvetronic design. This design uses a DC motor to control the profile at which the 12 total intake valves open and close. This design allows for the ability to vary the maximum lift of the valves based on the power needed to generate based on throttle position. The DC motor mentioned drives a worm gear on a semicircular gear of an eccentric shaft. The change in position of the gear will rotate the shaft, changing the position of the profile. This allows for variable lift and duration for the intake valves when the camshaft, intermediate arm, and rocker arm push the valve spring to open and close the intake valve. The N55 uses also what is known as a Van system in conjunction with the Valvetronic design. The ECU controls a solenoid valve to change oil pressure, which in turn forces a piston to move across camshaft helical gears. This change in oil pressure allows for the ability to advance or retard timing. For the intake system, the N55 uses the Valvetronic system along with a backup throttle body. If the Valvetronic system fails, you are able to limp back home. On the other hand, the intake system uses boost generated from the twin-scroll turbocharger. The 2 channels from the exhaust manifold spool up the turbine of the turbocharger and push air coming from the air intake through the intercooler and into the intake manifold. For the exhaust system, the N55 uses an exhaust manifold with 6 little runs to 2 outputs that is connected to the twin-scroll turbocharger. The turbocharger has 2 channels with cylinders 1 through 3 pushing exhaust fumes to the far left side, while cylinders 4 through 6 push exhaust fumes to the right channel of the turbocharger. Ideally, the runners should be 1, 3, and 5, and 2, 4, and 6, but to do so would require longer runners. This configuration helps with increasing low-end torque to spool up the turbocharger. At the catalytic converter, the O2 sensor is used to measure the amount of oxygen coming from the exhaust manifold to correct the air-to-fuel ratio going through the intake valves. By having the catalytic converter in place, a closed-loop system is used to correct the oxygen levels assuming starting at stoichiometric. This will reduce emissions by controlling the ability to oxidize carbon monoxide and unburnt hydrocarbons to result in carbon dioxide and water. The N55 is a force-inducted engine that uses exhaust fumes coming from the exhaust manifold to the turbocharger. The 50mm inducer and the 67mm exducer of the turbocharger sends the boost through what is known as a boost pipe to the intercooler. The air is then cooled via an air-to-air intercooler and sent through a charge pipe to the throttle body. At redline, the N55 can produce roughly 15 psi on a stock tune. However, there are a few failure points worth mentioning. The charge pipe that connects the cold side of the intercooler to the throttle body is made of plastic and tends to crack. Personally, I have cracked this charge pipe while going wide open throttle in second gear. The car went to limp mode, and my friends and I laughed. Here's a clip of a boost leak I've had in the past, along with photos of me replacing my broken charge pipe with my little cousin Leo. Well, that's the end of the video. I hope you were able to learn something new about the BMW N55 engine.